So we're on page 62, and in the previous video lecture we did greatest common factor and common factors in factor by grouping. And right now we're going to look at trinomials, the factor of trinomials. And the first trinomial that we're going to look at is one of a type where the coefficient of x squared equals 1. So we're going to factor this one. Coefficient of x squared is 1. And then we're going to look at trinomials where the coefficient of x squared does not equal 1. We're going to factor this one. Here you can see the coefficient of x squared is 2. And so this fulfills the requirement that x squared doesn't equal 1. So we're going to look at these two cases. And in the case of trinomial where the coefficient of x squared equals 1, we're going to factor x squared plus 2x minus 8. Now, if we write this as x plus a times x plus b, obviously we have to find a and b. So how do we find a and b? Well, if we look at minus 8, this must come about by the multiplication of a and b. So the minus 8 must come from multiplying a times b. So a times b must equal minus 8. And then if we look at the plus 2 term, this is the combination of the coefficients of the inner and the outer terms. And the coefficient here, ax, the coefficient is a, and the outer term is bx, the coefficient is b. So the sum of a and b must equal 2, which is this term right here. So the only combination of two numbers, a and b, that would when multiplied together give us minus 8 and sum together to give us plus 2 would be plus 4 and minus 2. If you multiply 4 and minus 2, you get minus 8. And if you add 4 and minus 2, you get 2. So the factors have to be plus 4 and minus 2. Now, so when we go back and we check this out, we say, okay, first times the first gives us x squared. So we rewrite this. We're going to check this as the answer. X times x gives us x squared. We've got the plus 4x and the minus 2x, which we combine, gives us plus 2x. The combination of the inner and outer terms gives us plus 2x. And the last plus 4 times minus 2 gives us minus 8. So that's a very simple way of doing it. And there's another way we can do it, which is longer, but we may find this useful in more complicated problems. So, alternate way to find the solution using grouping. We ask what two numbers whose product is minus 8 and whose sum is plus 2. Well, we just did that. Minus 8, just to go over, represents L in FOIL, which is combined by multiplying the last term by the last term, AB, in the previous problem. So we know that if we go up here, A times B gives us minus 8. So the plus 2 represents the combination of the outer and inner term. We saw that before, a plus b. Turns out that if we write the factors in more detail, we go into what the factors of minus 8 are. They could be 8 and minus 1. They could be minus 8 and plus 1, minus 4 and 2, and 4 and minus 2. This is the only combination that adds to plus 2. Okay, so we then write this as the 4 here, put the 4x, the minus 2, and the minus 2x here, and now plus 4x and minus 2x sums to the plus 2x. That is part of the problem. If we go back up here, you can see that this should be plus 2x. So that fulfills that requirement. Now, what we're going to do is take the first two terms. We're going to factor out x, and we're left with x plus 4. X times x gives me x squared, and x times plus 4 gives me plus 4x. From the third and fourth term, I'm going to factor out minus 2 here. So minus 2 times x gives me minus 2x, and minus 2 times plus 4 by the distributive rule gives me minus 8. So you can see that I've gone from here to here, and by factoring. So now the common term to this one here and this one here is x plus 4. I factor out the x plus 4. I'm left with this x right here. If I factor out the x plus 4 from here, I'm left with minus 2. So these are the common binomial factors of this. Now you say, well, why did you write this plus 4x minus 2x? Why not write it minus 2x plus 4x? Well, what you find is you'll get exactly the same answer. We factor out x from these two terms, and I now get x minus 2. And if I factor out 4 from these two terms, I get plus 4 bracket x minus 2. X times x gives me x squared. X times minus 2 gives me minus 2x. Plus 4 times plus x gives me 4x, and plus 4 times minus 2 gives me minus 8x. So I ask myself, what's common to these two terms? It's the x minus 2. I factor it out, and this x goes over here, and the plus 4 goes here. So this is identical to this answer. It's just the order of multiplication is different. Let's do another example. And here we're going to say x squared minus 7x minus 18. And we're going to write this as x plus a and x plus b as we did in the previous one. And here the product of ab must be minus 18. And the sum of a plus b must be the minus 7. So we ask ourselves, what two numbers when multiplied together give us minus 18 and sum to give us minus 7? And you can realize that it can only be minus 9 and 2. So you put your minus 9 here, and you put your 2 over there. And if you use the FOIL method, you'll get back this equation. Alternate way is to use grouping, and again ask ourselves what two numbers when multiplied together give us minus 18 and sum to give us minus 7. Here are all the possible combinations, but the only combination that sums to minus 7 is minus 9 and plus 2. If I take 9 and minus 2, I'm going to get 7. If I take minus 6 and 3, I'm going to get minus 3. For this one, I'll get plus 3. So the only one that gives me a sum of minus 7 is minus 9 and 2. So here, what I'm going to do is, again, go by grouping. I'm going to say x squared minus 9x plus 2x minus 18. So I group them. I factor out x from both of these. I get x minus 9. I factor out 2 from both of these. I get x minus 9. Now x minus 9 is the common factor here. And so I have x minus 9. Take it from this term. I'm left with x. And when I factor x minus 9 from this term, I'm left with plus 2. So that's it. So again, here, instead of writing minus 9x plus 2x, I could have written plus 2x minus 9x. Doesn't make any difference. I factor out the first two terms, I get this. I factor out 9 from the third and fourth term, get minus 9x plus 2. X plus 2 is the common factor, get x plus 2 times x minus 9, which is exactly the same as that. And you can see that the combination of the inner term here and the outer term gives us minus 7x. So that's methodology for factoring trinomials where the coefficient is equal to of x squared is equal to 1. Now let's look at a case where we have a trinomial where the coefficient of x squared does not equal 1. And we're going to use a method. I'm going to give a little different detail than shown here and go through it in a slightly different manner, but it's exactly the same as what's done above. So I'm just going to explain it slightly differently. So what we need to do here is find two numbers when multiplied together give us minus 18. Where do I get the minus 18? I multiply the minus 9 times the 2 and whose sum to give plus 3. So I need two numbers that when multiplied together give me minus 18, obtained by multiplying minus 9 times plus 2. The first number by the last number. That's the first thing we do. And then sum to give plus 3, which is the middle term. So 6 and minus 3 when multiplied together will give us minus 18. And when we sum them, 6 and minus 3 will give us plus 3. So now I take the 6 here and I put plus 6x. I take the minus 3 and I put minus 3x. And I group it. X is common, 2x is common to the first two terms. The highest common number is 2. And I take the lowest power of x here from these two, which is x, and I factor out 2x. And I get x plus 3 because 2x times x gives me 2x squared and 2x times plus 3 gives me plus 6x. From these two, I just take out the number 3. So I have minus 3. Minus 3 times x gives me minus 3x. Minus 3 times plus 3 gives me minus 9. So now I factor out x plus 3 from this term. It's also present in this term, and so I factor out x plus 3, the 2x goes here, the minus 3 goes here, and there we have the answer. Now instead of writing plus 6x and minus 3x, I could have written minus 3x plus 6x. It doesn't matter. I factor out x from the first two terms, I get 2x minus 3. I factor out 3 from this term, and I still get 2x minus 3 here. Now I factor out 2x minus 3, put it here. This x goes here, and this plus 3 goes here. So 2x minus 3 times x plus 3 is the same as x plus 3 times 2x minus 3. And if you use the FOIL method, minus 3x is the outer term, plus 6x is the inner term. We add those together, we get plus 3x. Now, let's take this case, a more complicated case. And 6x squared minus 7x minus 20. What we do is we ask ourselves, what are the two numbers whose product 6 times 20 or, and excuse me, this should be a minus. Let me just correct that here. There should be a minus here. So in this one I'm asking what are the two numbers whose product is 6 times minus 20. I multiply the 6 here times a minus 20 here, or 120, and whose sum is minus 7. So I multiply the first and the last numbers, minus 120, and I want to know what are those numbers who sum to minus 7. So there are many numbers that multiply together give you minus 120. For example, 10 and minus 12. But you can't sum 10 and minus 12 to give you minus 7. So you have to look for two numbers. The two numbers that multiply together give you minus 120 are minus 15 and plus 8. If you sum minus 15 and plus 8, you get minus 7. So now I put the minus, rewrite the problem, and I write plus 8x minus 15x. I can also write minus 15x plus 8x. It doesn't make any difference, as we've seen in the previous problem. So I find the factors now, and what I'm going to do is factor out 2x from these two terms. The highest number that goes into both 6x squared and 8x is 2. And I take the lowest power of the x's here, which is x. I factor it out. 2x times 3x gives me 6x squared. 2x times plus 4 gives me plus 8x. Now, from 15x and 20, minus 15x minus 20, I can only factor out the number 5. So I take out the number 5. Minus 5 times plus 3x gives me minus 15x. And minus 5 times plus 4 gives me minus 20. So you can see 3x plus 4 and 3x plus 4 are the common terms. I factor that out. This 2x comes over here, and this minus 5 comes over here. Now, if I do the same problem by instead of doing plus 8x minus 15x, I do minus 15x plus 8x, which both sum to give minus 7. I've just changed the order of these two numbers. I still come out with exactly the same ultimate answer. So what I do from these two terms is I factor out 3x. I'm left with 2x minus 5. From these two terms, I factor out 4. I'm left with 2x minus 5. 2x minus 5, 2x minus 5 is the common term. I factor it out. 3x goes here, and the plus 4 goes there. And you can again check that using FOIL. So what I've done here, I've done the grouping, and I factor, and then I get the common binomial factors, which is exactly what I did over here. Okay, so here, case 3, I've got 15x squared plus 29xy minus 14y squared. What two numbers, when multiplied together, so I'm going to multiply the 15 times minus 14 is minus 210, sum to give 29. So you see, that's quite a hard problem, and you have to do some mental arithmetic here to try and figure out. And the two numbers that sum to give 29 when the product is minus 210 is 35 and minus 6. So instead of writing 29xy, I'm going to write plus 35xy minus 6xy, because that's equal to this. And these are the possible factors. These are the factors that multiply together. When you multiply 35 and 6, you're going to get minus 210. And when you sum them, you're going to get to 29. So now I've got plus 35xy minus 6xy minus 14y squared. I look at these two terms, say what's the highest number that I can get out of both of these? It's 5. The lowest power of x is x to the power 1, and there's no y term here, so I can't factor out the y from the first two. So if I factor out 5x, 5x times 3x gives me 15x squared. 5x times plus 7y gives me plus 35xy. So out of these ones, what's the highest number that I can factor? It's the number 2. Since I've got an x to the power 1 but no x here, so I can't factor out x, the lowest power of y in both these terms is just y to the power 1. So I factor out 2y. 2y minus 2y times 3x gives me minus 6xy, and minus 2y times plus 7y gives me 14y squared. Now I factor out the 3x plus 7y, and it's right here. should have been the first term, but it doesn't really matter. This becomes this, and then I'm left with 5x minus 2y. So if I do this the other way, instead of saying plus 35xy and minus 6xy, I do minus 6xy plus 35xy. Out of these first two terms, I can factor 3x. 3x times 5x gives me 15x squared. 3x times minus 2y gives me minus 6xy. From these two terms, I can factor out 7y, and I'm left with 5x times 7y gives me plus 35xy. 7y times minus 2y gives me minus 14y squared. Common factor from these two terms is 5x minus 2y, which is right here. And then I'm left with 3x plus 7y. So I mean, in this particular case, I could have put the 5x minus 2y first and then got 3x plus 7y, but I get exactly the same answer. So if you combine let's look at the inner and outer terms. The 3x times the 5x gives me the 15x squared. The plus 7y times the minus 2y gives me the minus 14y squared. And I combine the outer, which is minus 6xy, 2x times minus 3y is minus 6xy, and here 7 times 5xy is 35xy. 35xy minus 6xy gives me plus 29xy. So this completes our discussion of factoring trinomials.